Okay, we're going to next look at the direct materials efficiency variance. So this would tell us whether we're being careless with the product, or maybe we have an inferior input that's causing a lot of scrap and we have to throw away a lot of the stuff, or maybe we're able to use less of the product for some reason, and that's on the hands of the production department as opposed to purchasing. So the price variance would be an indication of how well our purchasing department is doing, and efficiency variance is an indication of how well our production department is doing. And so one thing I want to point out, it probably doesn't make much sense, you probably don't appreciate it, is we're looking at this performance report. You can see that we have a $45,500 unfavorable variance. When I first looked at it, and I said, okay, well, a direct material variance is two things. That's the price variance and the efficiency variance. So if I know that I have a $55,100 unfavorable price variance, doesn't that mean that I have a favorable, to get back to 45.5, a favorable efficiency variance? And the answer is no, because this is a static budget. You can't compare a static budget to the actual results. So it's kind of misleading to look at it this way. And I'll show you what I'm talking about next as we look at the materials efficiency variance. Materials efficiency variance, and I know you can't, I don't have it all on the screen right here. I can't fit it on. Maybe I can. Let me just cut this up real quick here. Yeah, there we go. So here's the formula for the direct materials efficiency variance. It's the actual quantity of the input used times, and then you subtract the budgeted quantity of the input allowed times the budgeted price per unit. Okay, so I have something similar set up down here. And get this thing out of the way. Oh, get it out of there. Okay, sorry. So the formula is the same. We have 3 inputs for 1 pound of ice cream, and the inputs are the cream, the extract, and the actual bacon. So we're going to first look at, there it is again, we're first going to look at the actual input used, which is actually right here, and we got that off of the usage report right here. These quantities are the quantities I'm going to throw into the used column. So all I got to do is copy here and paste. And I now need to figure out the quantity allowed. What do you mean quantity allowed? Well, quantity allowed is a factor of this right up here. We have these standards that were set, and the standard said, well, you should only use 12 ounces for every 1 pound of ice cream, and 4 ounces of maple, and 1 ounce of bacon. So we take this and we combine that with the actual quantity of pounds of ice cream we produced, and you take 275 times the 12 ounces, and that's how much cream we should have used. 275 times the 12 ounces. So we should have used 3.3 million. Let me just get these numbers formatted the same here. It's easier to look at. And we didn't. We used less, so that's a good thing. So the difference is less. And we do the same thing for the remaining quantity allowed. You would take, well, the 4 ounces of maple are allowed, and we made 275,000 pounds of ice cream. You're allowed 1 ounce of bacon for every 275,000 pounds of ice cream, and so the difference is the difference between the two. And the budgeted price, we figured that out in the prior example, so I'm not going to go through that calculation again. I'm going to simply cut and paste. And now you take the difference, or the budgeted price, times the difference. So you would look at these numbers and you'd be able to determine whether we had so the sum of all of this is going to be my direct materials efficiency variance. So this is the number. We have to determine whether that's favorable or unfavorable, and you can tell that by looking at the price that we should have paid times the difference. So here's how I look. It's very logical to me to say, okay, we should have used, or we did use 3.12 million. We were allowed to use 3. This is a good thing, right? I used less material than I was allowed. So a negative number here is a favorable variance. So you take that quantity we saved that we didn't actually use, that we could have, times the price per unit that's budgeted. This is a favorable variance. But on the flip side, we used more maple extract, right? 130,000 ounces more, and that's an extra 12 cents per ounce. That's unfavorable. And the same thing here, we use more bacon. I bet someone ate it. I couldn't resist if I were making that. I'd be eating the bacon off the line. And so I'd take that 50,000 ounces times the 45 cents. I say that's an unfavorable variance. So the net difference here is we have an unfavorable variance. This is the answer to the third requirement. We have an unfavorable efficiency materials variance of 32,700. Let me just tell you again what I was talking about before. If you take both of these variances, it's logical to say, oh, I have an $87,800, they were both unfavorable materials variance. So why is my direct materials variance not 87,800? It's 45.5. Did we screw something up, right? That's the first thing I would think of. The answer is no, we didn't screw anything up. You're comparing an apple to an orange, 275 to a budgeted quantity of 300,000, so you can't compare the two together. Okay, that's the answer to the third requirement.